So from left to right with Derek Chiou, we have Timothy Pearson, Alan Clark, and Steve. Your last name escapes me. Thanks. And on the left is Bapi. You guys want to introduce yourselves?
Certainly. My name is Bapi Vinnakota. I'm with a company called Netronome. And I also run the Open Domain-Specific Architecture project for the Open Compute project.
All right, my name's Chiou. I'm an architect in Microsoft Azure and a research scientist at UT.
Timothy Pearson, with CTO Raptor Computing Systems.
Good morning. I'm Alan Clark. I work for SUSE, who delivers enterprise Linux software on many different architectures. We build software from the edge to the core to the cloud. And one of the reasons I'm here, I know I'm new to this audience, but believe it or not, I actually was heavily involved with Power back in the predecessor's days. And totally loved these announcements today, by the way. It's awesome.
My name is Steve Hebert. I'm the co-founder and CEO of Nimbix, which is a cloud computing company focused in high performance and accelerated computing space.
All right, excellent. So today is about open source hardware, but I thought it might be interesting to talk about open source a little bit, sort of how did open source start and really how important has open source been? And let's start first with software. And I'm actually very interested in hearing from each of you, what was kind of the seminal moment for you with regard to open software? You want to start, Derek? Or?
Sure.
Okay.
I can start. Well, I think my seminal moment when I was a grad student downloading Linux for the first time, I think it fit on 6 3.5-inch floppy drives. I loaded it up and I'm like, wow, this is really much worse than the SunOS Solaris AIX that I was using. So, but it very clearly changed very quickly.
Yeah. That's cool.
So for me, it was a long time ago, actually, but I was tasked, and I was with a proprietary company, and I was tasked with developing an SDK. And an SDK isn't something that you go out and sell and make tons of money on, right? And I looked and I said, well, it's already out there. There's stuff available. Why don't we just use that? And the company had never done open source prior to that. They didn't understand it. They didn't understand the governance that Mr. Cunningham talked about, right? So there was a lot of education there, but it was that moment for me that once we joined and participated, I went, aha, we can move fast, we can move rapidly, we can innovate, we can collaborate. I don't have to build it all myself. So I delivered something very quickly to the market, a solution that was widely adopted, was a de facto standard. Just everything outweighed my doing that all with a team of engineers by ourselves, for ourselves.
Mm-hmm.
From my perspective, I have to go with the Linux, the experiencing Linux for the first time and actually observing it with a little bit of skepticism, and I think, one of the talks earlier, talking about some of the risks and rewards associated with it. But I think that, as someone who had a background in electrical engineering and then, seeing it happen in software, and now this announcement from today is pretty fascinating for me from a hardware perspective. But, again, more personally, I think I can't imagine having, even as I started Nimbix, it was so much of the beginnings were based on the availability of open source software to be able to unleash innovation much more quickly. And I would venture to say that most startups in technology today, particularly in software, happen only as a result of, the birth of Linux and the ability to move so quickly. So for me, that's been the big one. And I think, today what's been announced is going to be really interesting to watch. And let's, go 20 years forward and look back on this moment is really going to be interesting.
So from my perspective, I'd echo the same thing. That first experience with open source was probably in the early Red Hat days, and it really left a lot to be desired at that point compared to competing solutions. But what really started to push myself and eventually the Raptor companies over to open source was that over time, that ability to actually dig in, to change things, to mold it into what your company needs, to remove things that you don't want in the software, that becomes vital. And then over the years, especially in the 2000s, you know, in 2010s here, it's become even more so, where the only way you can innovate is by actually having that base to build on. If you had to do everything de novo, you're going to run into so many problems, so much time spent, and it's impractical. This allows us to build on everyone else's work. You contribute the work back, and essentially everyone can find something that they're a niche for themselves or the companies, and you know, basically offer that many more solutions than would ever otherwise be possible.
My personal favorite is Python.
I'm sorry?
Is Python. I'm a pretty incompetent developer, so Python allows you to.
Yeah.
So I think something that makes other people productive more easily, where they can focus on. It's kind of underappreciated in my mind. So any kind of open source hardware that reduces the tax of building, in my mind, is something that's going to be interesting. And I think today's announcement kind of plays into that.
Right. So, and actually, since I'm an analyst, I'll throw a data point out there. Open source has grown to a point that by 2022, we expect that 50% of all the AI hardware in the world will be running open source software, not commercial AI software. And that, I think, it says something, right, about what's going on. Let's switch to open source hardware. How important is open source hardware in general for the sort of the ecosystem, the tech industry as a whole? Who wants to go first?
I'll go ahead.
Okay.
So from our perspective, what we've observed for a long time is that there has been a trend, obviously, for faster and faster chips, but it's also been kind of consolidated. When you really look at things, you have a tremendous amount of lock-in to essentially one or two vendors. You know, for the most part, it's two vendors. And this whole idea of whether or not those two vendors really have your company's interests in mind or not, for the most part, they don't care. They can't care at the scale they're at. They have to produce a single chip that's going to work across essentially every single market segment, roughly. I mean, you know, obviously there's some variations, it's the same basic design. And really we're at a point here where that sort of one-size-fits-all mentality is really starting to break down. You're getting to the point where you have various companies that have vastly different requirements, and even in the best case, there's almost no way that a single core design, a single chip design is actually going to fit all of those requirements. So where we're at is, if there's a single ISA that is only able to be manufactured, say, by a couple of vendors, you're at the point where you have massive software inertia that can't be overcome. Even if you came out with hardware, could develop the hardware on your own, you're not able to actually manufacture that. You can't fill your own need. So, for instance, the announcement today is absolutely vital for companies that have requirements that the larger vendors simply can't meet. It removes permanently the whole problem of the software inertia, locking you into a specific core that may not actually, from a hardware perspective, do what you want, or may do things, more importantly, that you don't want. So from this point on, we have the potential to permanently remove the software inertia concerns and to essentially allow diversification in hardware for the first time.
Al?
So that's great. You're exactly right. I'd add two things. One is supportability and reliability, right? As was mentioned earlier, you know, black boxes are hard to support. And one of the reasons the company I work for is a full open source company is we want to be able to support our customers. They want to know what they're running, right? They want to understand, they want to be able to look at it. They may not want to change it, but they want to understand what's running in their environment. And so having open hardware, it just continues that trust building with our customers, right? Enables us to support them we're not going to change the hardware, but we want to work with those that do and make sure that that our solutions and the solutions within the community are running in an optimal state, right? So we get that diversification, but it also opens it up and enables us to support that diversification and give those customers the reliability that they're looking for.
So I would say a couple of things that come to mind, from my perspective with open hardware. First, I think Anton's talk got me really excited. I want to go after this and to the Nimbix cloud, spin up an Alveo and download that microwatt PowerPC. I remember it from my days at Altera, when we talked about, getting IP blocks and processors, embedded in the FPGA. There was always a blocker on, is that IP available, or would the processor fit? And there was stuff you had to keep sacrificing in order to get these types of things embedded. And so to have the first POC, it wasn't even trying to squeeze it on. It literally barely took up any space. That was fantastic. So I'm super excited about that and what that means. And we want to go back and have our guys start. And all of you are invited. We can spin up some Alveos and start downloading some hardware. Is pretty exciting. I think the second thing that I take away it really struck me as Ken was talking this morning in his announcement is the whole notion of open governance to determine kind of how the hardware is propagated. And I think that's a really, I hadn't thought about it. You think of sort of, more of the freewheeling rebel, ISIS floating around and people, hacking on it. But the open governance is a really important piece for I think what was just said about building trust, but allowing the ecosystem to showcase the demands, of the users for what the hardware needs to do. And then you can go off and build those sort of the world's best processors. So very, very exciting from my perspective.
Yes, I agree with everything you guys all said. This is super exciting. I think that but this is really a very, very first step. I mean, I used to be a co-PI of there was a project called RAMP, Research Accelerator for Multiprocessors. What we tried to do is we tried to implement large-scale multiprocessor systems in FPGAs. And in fact, we went to IBM and said, will you give us the source code for the PowerPC 405? And they no, right, effectively. Fundamentally, IBM and many other companies, IBM was not the only one, basically saw their, this hardware as their secret sauce. But as companies have changed and are really making their money in other ways, I think kind of providing the very high quality industrial grade hardware and RTL and all of the tooling and other components that are necessary will uplift the entire industry and allow us to make much more progress. The way software is done, open source software is done.
Right.
So the interesting thing about open source software in my mind is that 2 or 3 people can start and build a viable product by reusing a lot of open source software with very little labor. And somehow open source hardware has to get to that point where you don't need this massive investment to make a new product from open source hardware. Yeah. So somehow the software guys have figured out the consumption model for the open source product that 3 people can do Instagram on a weekend. And but there's still a huge budget when you do hardware. Yeah. And so if you can change the consumption model with open source, and then iterate on improving the product once it takes off, that's and I'm assuming it's going to be different from hardware versus software.
And we've seen a lot of new hardware initiatives, right, recently.
There's a huge number in the past year.
And so do you think that with open source hardware, it will be easier than what these sort of startups have to go through?
Well, that's I think one of the interesting things is because hardware engineers have to look so deep into the future, they're typically much more unwilling to make performance compromises and area and power compromises. Yeah. And so if you don't have to make a big bet 18 to 24 months into the future, but you can iterate on your bet very rapidly, they're more willing to accept compromises. Yeah. So if the consumption model is I give you a chiplet or I give you a verified hard macro on a particular process node or something like that, it may not be optimal for your application, but if the cost of changing your mind is not too huge, you'd be willing to accept that. And I think that the big difference between hardware and software is the depth into the future into which you make your bets. Yeah.
So let's talk a little bit about specifically today's announcement. And I'm curious how each of you respond to it from the perspective of the business that you run or work at. What does it mean for your business, for your products, for what you're trying to do? And talk a little bit about how you think, does it allow you to diversify, to differentiate? Does it make things simpler, more complex? A couple of those things, if you could address those. You want to start, Steve?
Sure. I think my reaction, there's certainly just taking it all in and processing it. And from a cloud company perspective who invests and scales infrastructure, the immediate one, and when we do both Power and x86, and one concern I have is a point that Aaron made regarding being careful not to go back into silos. And sometimes you have open source movements that compete with other open source movements. And so you can see that there's risks of the open hardware initiatives, sort of clashing with other, hardware approaches. So I think that's something that, we're going to have to see how things start to play out. But I think philosophically, highly energized because it is the path forward. I think that with Moore's Law, coming to an end, innovation in silicon, as opposed to sort of, running down the path of, shrinking transistors, it's now more about opening up how do we configure those transistors in unique and optimal ways to solve our problems efficiently and quickly. And so I think from a ecosystem standpoint, that's something we are very much, wanting to foster and continue to drive. From a business perspective, it's always, how is that all going to start to shake out? So I think we're going to, be along for the ride and be a part of that ecosystem so we can help, steer it and participate with the ecosystem.
Mm-hmm.
Going down the row? Okay.
Yeah.
So I guess from our perspective, you need to understand we support a wide range of hardware platforms, right? From the x86s to the mainframes to the powers to ARM to, you name it, we're probably there. So I'm very excited about this one, as I mentioned before, is the supportability perspective. But two, as I also mentioned earlier, we're supporting and building software all the way from the edge to the cloud to the core, right? So all these different environments. And our customers pick the hardware they pick the hardware because it solves a problem, right? Be it large cache, multi-threading, whatever. They're basically looking to solve a problem, and they want to do it, the least expensive way and get the most for their buck, right? Fastest performance type of stuff. And power, the power consumption models, all those things come into play. So I'm excited about this because to me it means we're going to be able to get a diversity of workloads running on these chipsets in different hardware environments, different software environments. And so I'm excited about the diversification, the potential diversification use of this power in different environments and our being able to support that.
So from our perspective, there's a little bit of background about Raptor. Many of you already know. We actually selected OpenPOWER several years back, largely because of our focus on owner control and security. Our philosophy is that the owner of the computing hardware should always have full control of it. It should only answer to them if they purchase it. Really what this announcement does for us is it allows us to guarantee going forward, barring some major shift in the industry, that we will always be able to do that. Even if we have to manufacture custom silicon, we will always be able to offer that. And up until today, that was not always a guarantee. We do what we can, but this announcement guarantees going forward that they'll always be possible. It also allows us to greatly diversify. I mean, everyone who's used one of our existing machines, right, which are now OpenISA machines, knows how large that Power 9 device actually is. It's a server chip. It fits in desktops barely. this announcement finally opens the door to, hey, maybe power can actually go down. Maybe we can replace the ARM core in our BMC with a power core. You know, things that we've been working on for a long time suddenly become possible and viable for the first time. This is great.
Yeah, you guys have been on this journey with OpenPOWER for quite some time, right? And so this must be sort of a seminal moment for you too, as Raptor.
Yes, it is. We've really been behind the scenes working with the OpenPOWER Foundation and to some extent with IBM, obviously, to try to really kickstart this and try to make this happen. And it's amazing to have watched it actually organically grow, you know, within IBM, within the foundation, and you know, finally take flight, you know, here today. And like I said, it's something that we can finally get rid of that lock-in for software side, and we can finally really see the diversification on the hardware side.
I'm going to sound like a broken record, but the intriguing thing about the OpenPOWER thing is it's kind of releasing the ISA after a whole bunch of applications have been baked in and a whole ecosystem has been baked in. And so the other parallel effort is the ISA got released, and then you're trying to figure out what to do with it. And so if you can make it easy to consume applications, not the ISA, that you have you have the accelerator you have, and somebody can come along and leverage 80% of the open ecosystem to build their unique accelerator really quickly. So if there's an emphasis on consuming and developing an application as opposed to just the ISA, I think that would be pretty exciting. It's a pretty unique role available to OpenPOWER and OpenPOWER ISA.
So is that how you're seeing sort of leveraging this within Netronome?
The potential is in the open domain specific architecture. We're trying to, the group as a whole is trying to build an open interface between chiplets, and where you can assemble instead of building a monolithic die, that you can assemble a product as a collection of die. And we still have the group has to settle on a logical interface between chiplets and how these chiplets work together as single die. Now, if something like an ecosystem exists where you've got an ISA and the consumption model of how accelerators interact with the ISA becomes very interesting.
So speak from an academic, wearing my academic hat, I think this is fantastic. I think this could really enable a lot of research, which frankly is kind of stalled because we haven't had access to the appropriate ISAs and actually the good implementations of those ISAs. So if IBM and other companies continue to push out, you know, I love your little core there, but if we could actually look at some of the real implementations along with the ecosystem and allow us to modify them, and if they could run on an FPGA, this would be fantastic. I think it would really enable a lot more research.
What is the impact on sort of competition in the industry? Will we see increased competition because of a phenomenon like this, or more sort of collaboration and competition? Anybody have any points of view on that?
Yeah,
go for it.
Yeah, I do. So from my perspective, it's really going to depend on where we go from here in terms of actually, like you were saying with hardware design, what is actually available. If we can rapidly develop essentially a set of cores, definitely in collaboration with an IBM and other players here, there's a potential for the Power ISA to actually become the dominant ISA, in my opinion. That being said, the competition is actually going to get more fierce from here on the hardware side. Just because you have a common ISA, which basically allows that software to run on any hardware, does not mean you're going to have less competition. You're going to have more. You're going to have hardware vendors that say they're going to be able to, and probably rightfully so, accelerate certain workloads far beyond others. You're going to see specialization. So it's not going to be competition like we know it today, where you have basically 2 or 3 major players all trying to knock each other out of the race. It's going to be more of for a specific workload, you're going to select one vendor. For another workload, you might select another vendor. For general purpose computing, you might select even yet another vendor, that sort of thing. And we're already seeing this occur with accelerators, right? The only vendor that is really saying, hey, you can do all your workloads would be the FPGA vendors. Everyone else is saying, hey, our accelerator can do this workload, our accelerator can do that workload, and you select whichever one you need. Fundamentally, I think we're going to see the same thing for CPUs.
Mm-hmm. Yep. Anyone else have any point of view on that? Or Steve?
Yeah, I think that ARM is an obvious one that's going to be interesting because it's based on royalties and IP licensing of their cores. So I think it's going to be disruptive from a processor standpoint. It'll be interesting to see what happens on the x86 side longer term. As this continues to gain momentum. And I think though what's interesting is having even the move of hardware being opened, what that will do with the software developer ecosystem, knowing that there's an open hardware, and that could have a stronger gravitational pull than we might predict. And I think that's going to be interesting to observe over time as well.
My hope is this will encourage other companies to open. It may be hard for ARM and Intel to do that. Because they have their dominant positions in the marketplace. But if there's momentum behind this, which I think really requires releasing more and more into the open platform, and this really has to probably be driven by IBM. That at some point, yeah, there may be this tipping where people like, well, I'll just use this; it's good enough, and I can modify it the way I want it to, the way I want to. So.
In the chiplet world, somebody brought up this question about security. How do I know that if I buy a third-party chiplet, it's not a malicious chiplet, or it's somehow going to impact me in some fashion? And if you're building a CPU chiplet, you might come to the point where somebody says it has to be an open ISA so that I know what's baked in, I know what the expected behavior is, or an open implementation, so I have some full insight into what it's supposed to do. And so the one interesting sort of leg up seems to be that open implementations and open ISAs may actually be preferred, just like Linux seems to be the sort of OS of choice for hardened systems. Yeah. That you might have a similar advantage in the hardware world.
Yeah. A few other just streaming thoughts here on that, and Derek may have some perspective with Microsoft. But what the hyperscalers choose to do with this will be interesting, and not just the U.S. hyperscalers. Knowing that there's already work going on to create their own silicon, to be able to unlock from sort of the traditional vendors, potentially completely, is interesting to see what dynamics that creates in the market. I think also from the system OEMs that again have followed this cycle for decades, of sort of the way technology hardware is released, developed, and so forth. So I think that again, this is feels very disruptive, and I think the reactions that people experience are going to be everything from dismissive, like no big deal, business as usual, but then allowing that small community to keep driving something that potentially gets quite large. But I think the hyperscaler reaction to it again, and you're already seeing that tug with Epic. And AMD making inroads, ARM, having some footprint inside of AWS, and so this could be a game changer from that perspective.
So Aaron was earlier saying, historic day. Do you guys agree today?
I definitely think it is. Like I said, I was involved with a predecessor to this organization, and I'm excited about this because we're addressing the things that just wasn't the right time for them to happen back then, but they were also barriers. And so I'm seeing those barriers fall. And that's why I'm excited about today's announcements, is because I think it's going to definitely accelerate this environment.
Anyone else? I think we could probably allow some questions at this point from the audience if there is an interest in posing a question. I'm not sure if there are microphones going around that we could use,
we'll
but
give them
the
ours.
room is probably small enough. I guess we have some microphones here. Anyone have a question for any of the panelists? Over there.
Earlier you said that in a certain amount of time, roughly 50% of all the software that's used is going to be open source. I wonder how the gentleman that run UT Austin and Microsoft Azure, what you think about that. How's that going to affect Azure and the whole
Well, Azure at this point, I don't know if we've tipped over to 50% Linux or not, but we're if we haven't, it's very close. And so we're already seeing this is, this is the way the world's going. And it turns out, I mean, Microsoft has bought GitHub. We probably check in more into Linux than anyone else. I mean, at least from what Microsoft is doing, we're very supportive of the open source, and we think that's that at least in my opinion of what Microsoft sees, that's where things are going.
Other questions?
Just a comment about the ecosystem being so critically important. Early days, and there were concerns about the instruments of control of intellectual property, and organizations like OIN popped up that made it safe for people to come out and play. The move to OpenPOWER under the Linux Foundation, the majority vote in the working group, and the patent licensing that was described, only touched on, those are absolutely critical pieces to permit the innovation to continue. So if you're thinking about it, we tend to think about technology, we tend to think about software. The environment is very, very important to focus on.
Mm-hmm. Yeah. I know academics who basically ARM went and very politely said, stop working on building an ARM ISA RTL or simulator or whatever. This is something which has been, I think has really kind of stopped or slowed down research, and that should be done. I think the fact that this is open from a legal perspective is critically important. I think is going to be a standard. It's going to be something that I think other people should be following.
The only other comment I make, which will appear self-serving, is IBM was not exaggerating when they said they were in the forefront of open. Open Invention Network was I was there when it was created. Was wholly created within the four walls of IBM Corporation, and so their ability to be an effective steward on some of those issues has certainly been demonstrated in free and open source software.
Thanks.
Yeah, totally.
So one of the big things hardware companies are, sort of open source software seems to have settled on a free model in terms of, and the big open question is, given the big investment in developing and implementing and validating hardware, whether free is a viable model or there has to be some other licensing model which still enables fast consumption, but that seems to be a huge difference between hardware and software, that universally hardware companies are not comfortable with free licensing. As we've put in a lot of person years worth of labor into this, into validating analog circuitry on a new process node, or debugging and verification, and free is a loaded word. So that's a big, I don't know how it gets resolved, but that's a big issue really that keeps hitting us in our project.
I mean, but software developers have to do all that too, right? And so I know that hardware has its own set of challenges, but yeah, if you look at how much work the software developers do to develop and verify and deploy and all that, that's...
I think there's a feeling that software people can change their minds, and the hardware cycle is so extended that the penalty is severe. And that I don't know what the answer to that is, but that's a major challenge.
That's a valid point. Yeah.
Fundamentally, I'm not sure where opening the ISA is really going to open those kind of challenges. I mean, you're going to have people collaborating, I would expect, largely on FPGA type implementations, only those that actually pass, and it's still going to come down to business concerns, only those that you can demonstrate to the appropriate business leaders, appropriate people in that space are actually going to make their way to real silicon, at least in the commercial sphere. Academic sphere may be a little bit different, but fundamentally we do have a prototyping tool. You could think of it maybe more in the early days of, I don't know, mini computer revolution, that sort of thing, where yes, you needed, for a large project, to actually commit serious resources, you needed to have time on, for instance, a mainframe or a large machine. Yes, you could do your initial work on a much, much smaller, much more limited box, but if you were actually going to commit and go forward with the project, you went up, you paid the money for the resources to actually create the product. And I guess for silicon, I guess how is that a whole lot different? At this point in time, we have a ton of old process nodes, we have a ton of information. What we currently lack and this was brought up before, is the actual open tooling to take something from HDL or even RTL and actually convert it into anything that can be made at any of those fabs. And that's something that's going to need to see serious work before we can even think about the commercial considerations of really open silicon. This is a first step. This allows companies that have the resources and want to commit to design, create, manufacture their own silicon. It does not solve those underlying problems yet. And that's where the community as a whole, I think, still needs to say, and this is where actually we're going to need foundries really to kind of commit to this whole concept, is that how do I put it, the older process node information is not proprietary, or that it can be brought in a standard interchange format into open tooling, where we can actually do the design work, actually do the validation work, do the simulation work, and prove that something's going to work before you actually commit to manufacture.
I just said that sounds like a lot of fun, actually. It does. It just makes you want to get in there.
Any other questions? Up there?
Kind of a vision statement or a vision question, crystal ball question. From this announcement, what do you think you see happening in industry 5 years out as a result of all this openness? Crystal ball moment.
Crystal ball question. Who wants to take it?
I think that's Garrett, isn't it? Wow, it's nice to see you, dude. So, to me, it's part of a trend, right? So you and I have been in this business for a long time, and we talked about the early days of Linux and the years it took for acceptance of Linux into the enterprise, right? And then all these other projects. I think it was Ken that showed the slide of IBM's contributions to the different projects over the years. But what you're seeing is the speed of adoption, right? It didn't take the 25 years for Linux, it didn't take Linux 25 years, but we can argue when it tipped the scales into the enterprise, right? But you can see the impact. And the impact is, my point is, it takes much less time nowadays for that impact to be real and to be adopted by not just fringe and not just early adopters, but to be hardcore enterprises, right? You can't fly in an airplane today without it being run on Linux. You can't, those planes are directed in the skies by Linux. Your phones, everything we do is touched by open source. And the speed of adoption is totally accelerated. So 5 years from now, I think we're going to be blown away, simply because the adoption curve is so fast nowadays. And it's not just open source. My point is the adoption of collaboration through open environments, through open governance, and so forth, is changing our world, right? So, like I said a minute ago, it's going to be fun to dabble in the silicon, and I think it's going to happen. I think we're going to be surprised at what's going to happen in the next 5 years.
So I'll go a step further, and maybe this isn't quite a 5-year vision, might be a little further out. But I was thinking about it as we were talking about, the RTL for these, the instruction set architecture. That becomes data available when you bring that into the ecosystem, and the number of people, the number of implementations, or the ability to scale that horizontally becomes data. So then you imagine that being used with deep learning, and AI, and you start to think about what can happen now when we take the machines themselves and allow machines to take that, now that it's open, it's all data that can be used and fed into these neural networks and allow machines to actually design themselves, which I think is really interesting.
You want to
My
do
narrow
a
prediction
5-year
is-
prognosis? Okay.
My narrow prediction is, I think there's the one interesting thing is now you can do a new many-core architecture. You're kind of like limited if you're going many-core. Right now it's either ARM or RISC-V. This is a really interesting thing where you can see 128, 256, or the microwatt or some cousin of the microwatt. Yeah. And because then you have the academic innovation and interconnect between many core. So what I'm thinking is in 5 years, there'll be at least one or two many core PowerPC architectures, and that might actually be specifically interesting to our company as a use case. So I think there's a new entrant in the many core.
So I would say it's kind of hard to look that far in the future in some ways, but one of the first things that this is going to do, the most obvious low-hanging fruit, is it's going to enable the ability for people to actually trust their computers again. If you purchase an open ISA chip, the first step, obviously, at least where we are right now, is that you can go down to the firmware, you can go down to the ISA, you can verify everything, you can know what's actually happening with that device. I think that over the years, and this is where I say I'm a little uncomfortable on timing, because I know, as from a hardware background, how long this can actually take. But over time, what we'll see is that you'll be able to peer further and further down into that stack, and you'll be able to know more and more that what you have in front of you is actually doing what it's supposed to do, is not working against your interests, is not going behind your back. So to a certain extent, in an era where people are giving up Google, they are leaving their cell phones outside somewhere or whatever when they're doing sensitive work. When you literally go into a company, it says no cell phones, no, they're literally technologies are being banned because of security concerns. All of a sudden, we can actually see the technology go back into those environments and actually assist rather than have to be eschewed based on these concerns. So it's a really big deal there. Fundamentally, though, going forward too, I suspect what we're going to see is some degree of consolidation in the software space. Right now, just right off the bat, right now, even in the commercial software space, we see vendors having to support x86, ARM, Power, even to some extent RISC-V at this point is really coming up too. And bluntly, from a software QA perspective, what we're seeing right now is that that's a bad experience overall. Each one of those software packages has a dominant architecture that developers are using, and that, for the most part, with the exception, unfortunately, rare exception of some software houses that take QA seriously, means that the development architecture is the only one that the software is properly functional on. I realize that with open source, thankfully, there's more community QA that goes into it, so that's been largely smoothed over. But especially for those vendors that are still using at least proprietary license or sort of an open source but don't touch model, that's a significant concern. It's a sort of a drain of QA. So as you go in the future, I would expect that there be some consolidation, assuming that things are executed correctly, that we don't end up with every vendor having a problem kind of situation, that there be some consolidation around an ISA or a couple of ISAs so as to avoid that whole software issue. And then from that point on, like I said, I do see hardware diversification, literally accelerators on steroids, the ability for the CPU itself to be swapped out or to be modified or purchased, whatever, to meet a specific application. So very much a heterogeneous computing future, I would think.
Yeah, so for me, I'm hoping that, and it's going to be longer than 5 years, but I'm hoping that the open source, kind of hardware will look very similar to open source software. That we're going to have technologies that allow us to prototype, develop, deploy, and actually build real chips that allow. I can do it in 3 months for $10,000 instead of what it takes. You all know very well what it takes today. And if that happens along with the continued advancements in open source software, we can actually start thinking about really open systems, which I think are, when you multiply the two together, is just really gonna revolutionize our field beyond what we've seen before.
Other questions? Yes.
I'm going to take one. So there were 2 parts of the announcement. You guys have been focusing on the ISA side, and I know that's the bigger hurdle. What, as far as the interconnect technologies that are coming into as well, the memory interfaces, the accelerator interconnects, how might that be something that might be taken advantage of a little sooner than producing a microprocessor or an ISA chip? How could those interconnects change and ratify and quickly help innovation around system topologies?
I guess from our perspective, that's part of the announcement that I'm excited about, because as we've talked about, it builds that trust all the way down, right, the different layers. But one of the things our customers are looking for is consistency across all the different, as I mentioned, we run on all these different architectures and platforms and devices and so forth, right? But our customers are expecting expecting consistency. And the excitement I have on this is our ability to help them achieve that consistency, right? The consistent feel, look, use, reliability, sustainability, all the abilities that you can name. But the key word there is consistency. It's going to enable us to bring and help them maintain that consistency across all their deployments, whatever architecture those will be.
I mean, to me, the interconnect's more important than the ISA, much more, right? Because for exactly the same reason, now I can plug a RISC-V with a AMD with a Intel processor and an ARM processor all in the same system and have them all use the same interconnect. That's fantastic. So.
Yeah, we had a conversation. I think the interconnect has the potential to help disaggregate inside a package and maybe make new commodity chiplets, like a memory chiplet is an obvious thing that could potentially be possible because of a disaggregated interconnect. So the ability to sort of build heterogeneous systems will be driven by the interconnect in my mind.
I deviate a little, and I'd say here that the interconnect, while important, it's a package. We can't have one without the other. You mentioned, for instance, integrating AMD chips, but the simple fact is, without you having access to AMD's technology, there is no interconnect. There is no connection.
Again, the hope will be that as people say, hey, this is a great interconnect, I'll start developing for it. Other people are like, well, I'll adapt to it, and then, yeah, hopefully it'll move in the right direction.
One can always hope, but I would just kind of mention in the industry, look for ages at AMD's HyperTransport versus I think it's Intel's QuickPath. They do the same thing. They don't talk to each other, and despite all the advantages of being able to do that, it hasn't happened. So, I think there's some sea change that would have to occur at those companies to make it happen. But the OpenISA is a good step in that direction.
So we have 1 minute left. So let's do one more question and then very quick answers. So. Okay, go ahead.
More of a practical question. I can imagine all sorts of wonderful things in crystal balls. Thank you for asking that second question. For me, in looking at communities and being part of the Linux Foundation, I think it's a wonderful start. But what do you see as the heavy lifting required in the short term? It's my understanding like 90% of the open source communities fail. Right? So, given that, what is the heavy lifting required to actually build community? Obviously includes research communities. What would be your view in terms of success in the short term?
Who's going first? All right, Derek, you want to go first?
So for me, it's the ability to interconnect the components, right? So what winds up happening is anyone who's done RTL development knows that we tend to optimize our interfaces too heavily, so that if I try to plug one block into another block that haven't been designed together, it's probably not going to happen. So having an abstraction that allows me to, effectively do function calls like we do. I mean, there's a standard C function call. It doesn't matter which compiler produced the executable, the object file. I can go and call across between two different. One piece of C code can call a function that was developed potentially by another compiler. Until we get to the point where we can go and snap things together very quickly, I think we're going to have a hard time because people are going to be spending all their time writing gaskets between the various components.
I would build on that some, and I would say that I think one of the key things we're going to need in the relatively short term is we're going to need open FPGA tooling. Obviously, ASICs, hard silicon, there's a lot of challenges there. That's not a short term, that's a medium to long term issue. But in the interim, we need to be able to develop that technology, and for the most part, that's going to require the community to come in here and actually collaborate on and basically add that new functionality to the tooling. And that's something we can't do if we don't have open tooling available to target these FPGAs. Now, there are a few projects that are, for instance, available now, but I'll just bring up an interesting issue. For instance, the microwatt core is VHDL. Those projects accept Verilog. So there's interoperability concerns all up and down the stack, even starting at this relatively high level of software.
All right, we're out of time, and I think what was earlier said. We're 1% there, It's a lot of work still to be done, but still an exciting moment for the industry. Thank you, gentlemen, for your comments, your insights, and thank you, audience, for your questions. Great discussion. Thanks very much.